Hello and welcome to Lesson 2 of our Unit 4 of Study on Quadratic Functions. In today's lesson, we are going to talk about how to graph quadratic functions of the form y equals ax squared plus bx plus c, and we're also going to use functions, tables, and graphs to determine and compare rates of change presented in various forms. So today, before we get started, let's remind ourselves of some of the vocabulary from the previous lesson. We remember that a quadratic function in standard form creates a graph called a parabola. This parabola has a vertex that can be the maximum or minimum of a graph, and it also contains an axis of symmetry, which goes through the vertex and divides the parabola into mirror images. As we go along today, we are going to look at how to graph these by hand. So let's take a look at our first example. When we are graphing a quadratic equation, we can do so in 3 easy steps. The first step is to find the x value of the vertex and the axis of symmetry, and we can do that by finding the value x equals negative b over 2a. After we do that, we are going to plug the x value into the original function to find the y value of the vertex, and we're going to go ahead and plot that vertex on our graph. Step 3 is we are going to create a table of values by finding a point to the left and to the right of the vertex, and we're going to plot those points and connect the graph in a parabola shape. So let's take a look. Let's graph the equation y equals x squared minus 6x plus 2. So the first thing we have to do is determine our a, b, and c values. So we remember that a is always in front of the x squared, b is in front of the x term, and c is the constant. So anytime we look at a parabola or a quadratic equation, identifying those first helps us to get to the next step. The next thing we do is we have to find the x value of the vertex. And the formula for the x value of the vertex is x equals negative b over 2a. And since we already identified our a, b, and c terms, we can plug those in there. So negative b, and b is negative 6, over 2 times 1, or 2 times a. So a negative times a negative gives us a positive 6, all over 2 times 1, which is 2, and we can simplify that one step further, and 6 divided by 2 is 3. So the x portion of our vertex, if we are kind of collecting information over here, our x portion is 3. It also means that our axis of symmetry is the line x equals 3, because it is the vertical line that goes through the vertex. So in that one step, we can find 2 parts. The next step says we need to take that information, this x value, and we're going to plug it into the original equation. So we get, so we're on this step, we get y equals, and my pattern says x squared minus 6 times x plus 2, and my x value is 3. So wherever I see an x, I'm going to put in a 3, and I'm going to simplify. So y equals 3 squared, which is 9, minus 6 times 3, which is 18, plus 2. And we can see that 9 minus 18 is negative 9, plus 2 is negative 7. So the the y portion of our vertex is negative 7. We can go ahead and plot the information that we know so far. So my vertex is at 3 negative 7. So on my graph, the origin is always 0, 0. So I'm going to go 1, 2, 3 over, and 1, 2, 3, 4, 5, 6, 7 down. So 3, negative 7 is my vertex. I also know that there's an axis of symmetry that goes through that vertex. So we can draw it, and we usually draw the axes of symmetry as a dotted line. So that is our axes of symmetry. If we fold our parabola above or through that, then they should match on each side. And let's just talk about our equation. What else do we know about this equation? Well, we know that our a value is positive, so a is greater than 0, so that means that our parabola should open upward, and we should have a minimum value. So when I do this next step, I should see my curve start to form so that it looks like a U shape. So let's take a look at step 3. Step 3 says I need to create a table of values. So I'm going to create a table of values so we remember what a table of values looks like here. And in this table of values, I'm going to put my vertex in the center. And I'm going to strategically pick 2 other pairs. I'm going to pick an ordered pair to the left on my graph of my vertex. So that means of x value that is less than 3. So I'm going to pick 1 because that's a pretty easy number to plug in. And I'm going to also pick a value that's to the right of 3. So I'm going to pick 4 just because it's a nice easy number. And I'm going to complete step 2 again by plugging in these x values. So now I have y equals 1 squared minus 6 times 1 plus 2. So I get 1 minus 6 plus 2, which equals negative 3. And then I'm also going to complete this for the other x value. So y equals 4 squared minus 6 times 4 plus 2. So I get 16 minus 24 plus 2. So that is negative 8 plus 2 is negative 6. So now I can plot these 2 ordered pairs on my graph and use my axes of symmetry to help me plot some extra points. So I'm going to plot these. So 1, negative 3. So 1, 1, 2, 3. And we can see that this point is 2 away from our axes of symmetry. And because of the symmetry, we can then plot it over here, 2 away from that axis of symmetry on the other side. And then we can plot 4, negative 6. So this is 3, 4. Negative 6 is 1, 2, 3, 4, 5, 6. And again, with our symmetry, we notice that it's 1 unit away from our axes of symmetry, so we can plot that same point on the other side. And look at that, our points are starting to connect in a U shape. So we can start graphing the best we can in a U shape. So from there, we can say our vertex is at 3, negative 7. Our axis of symmetry is at x equals 3. We need to know the domain. And we've learned that the domain for a parabola is always all real numbers. And we need to learn the range. So in this case, my range starts right here at the y value of negative 7. And my parabola opens up. So y has to be greater than or equal to -7. Take a moment to pause the video and review our work. Okay, now let's take a look at a real-world problem that involves a quadratic equation. The most common quadratic equation that we use is the vertical motion model. And the vertical motion model says I can determine the height and the time of an object flying through the air based on the formula h equals -16t squared plus vt plus c. H is the height above the ground, t is the time the object is in the air, v is the initial velocity, and c is the initial height. So let's take a look at our question. Daniel kicks a soccer ball into the air with an initial velocity of 64 feet per second. The ball is 2 feet above the ground when it is kicked. So before we even tackle the questions, let's model this with a picture. So down here we have our soccer field, and we are going to draw a graph on our soccer field of our soccer ball and its height based on time. So our height, our soccer ball starts at 2 feet, and we know that when we kick something, it's going to go up and then it's going to come down to the ground. So our motion of our ball looks something like that. Now let's use the formula and our information about parabolas to help us answer our questions. So we're going to start with our vertical motion formula. H equals -16t squared. So our variables in this formula are h and t, and so we want to talk about ordered pairs as t and h. So time is our x variable and height is our y variable. So as I look at this, my h is my y, my t is my x, my v is my initial velocity. And in our problem, our initial velocity was 64 feet per second. So we can say that's 64t plus, and c is the initial height, and the ball is 2 feet above the ground, so c is going to be 2. So we can determine that a equals -16, b equals 64, and c equals 2. Now let's take a look at our questions. How long will it take the ball to reach a maximum height? So I want to know how long it will take the ball to reach a maximum height. So we first have to know where the maximum height is. Well, the maximum height is going to be at our vertex. And time is our x value. So we are looking for this x value. And we know that we can find the x value of a vertex by saying x equals -b over 2a. So let's go ahead and plug in our values. X equals -64 over 2 times -16. So we get -64 over -32. So that equals 2. So this value right here is 2. So my vertex is at 2. And so the initial, or how long will it take to reach the maximum height, is 2 seconds. And how high above the ground will it be? So if I look at my graph again, we can see that the height of the ball is going to be my y value of my vertex. And we know that we can find that by plugging in the x value from above. So anywhere I saw a t, I'm going to put a 2. So 64 times 2 plus 2. So we get -64 plus 128 plus 2, which gives us 66. So the height of our ball is 66 feet. And our range, our graph goes from 0 when it hits the ground to 66 at its height.